formulas. Chapter 5 was geometric and arithmetic before we did Fibonacci. So in chapter 5, so you got this dude. What's this for? Oh, rough spot. Board. What was that for? For what? Yes. Cool. So a sequence that adds. I think somebody was saying something about adding over there, but I couldn't quite hear you. So a sequence that adds arithmetic. I like it. All right, that's the one that makes sense. A, arithmetic. Yay. G, multiplication. It's a silent G. Multiplication. So this is arithmetic. What's the sum formula for that? That's the one that little Gauss dude, little show-off dude, when he's young, did that thing with the teacher. I don't know if you remember that. Urban legend. Or this, if you add the first one to the last one, it's going to repeat this many times. There's going to be this many pairs of the same sum. So the idea behind the formula is very simple. It's really nice. So that's for arithmetic. And then for geometric, it's based on what? Arithmetic's based on addition. Geometric's based on multiplication. So what letter do we use for it? R, to indicate the common ratio. Cool. And this D here is the common difference, since you're adding the same thing over and over. Cool. Sounds vaguely familiar. And then to sum these up, there's a little bit more disgusting formula. I think I actually showed you the derivation of it in class. You're like, I'm sure you did, Jeff. It's that guy. Very obvious, right? Of course it's that guy. What else could it be? No, it's not very obvious. It's weird. Alright, so that's chapter 5. Those 4 formulas for arithmetic, geometric. Fibonacci is an idea. You have to know the idea for Fibonacci. What's the golden ratio? Who remembers what that is? What the value is? Almost? 1.618. Alright, cool. I like it. Yeah, like, yeah, you would know, Jeff. Yeah, of course. Alright. So there's no formulas for Fibonacci. And then we got into, let me see if I remember correctly, we skipped 6, 7, and we went to 8, conversions. So we have the metric system, which you have to know. What's the little saying to remember how to convert within the metric? Some England person. King Henry. Died Monday. Drinking chocolate milk, I like. Right? And the Monday is the operative word, because M for meter, but it could be a liter in there, it could be a gram in there, right? Died laughing, died giggling. Right? I like it. Cool. He just died. That's the basic idea behind between all those 3. Poor little dude. Oh, there's Fibonacci back there. Great things. Let me think. Where was I at? Chapter 8. So there's metric system, there's the areas, the volumes, there's, say it? Temperature, I like it. So that's the formula we can use. I remember on this little sheet I gave you the conversion from metric volume between cubic centimeters, for example, and liters, and then how that translates into mass of water, H2O, right? Just to get around the way to say water. So the temperature, remember what this one is? Nobody, okay. 9/5. C plus 32. 32 is a magic number for what corresponds to 0, right? And then this guy is just the reverse, so it's 5/9. F minus 32. Be very careful, that's parentheses and that's not. If you put parentheses in the first one, you've made a new formula that doesn't exist anywhere, so it probably will give you wrong numbers. So don't do it. It's a bad route. You're going to have a bad time. Let's see, what else we got? Chapter 8, conversions, grams and stuff. I don't remember any more formulas. Any other formulas that you have to request? You can make requests, because I'll shoot a lot of them down, but you can still make requests for things to be on here.
Yeah. along with the sheets for the different number systems, you're going to have the conversion sheet, right?
Yeah, it's all in there.
Oh, okay.
Yeah. At the bottom of that's got 1 mile, so many kilometers, all that kind of stuff, yeah. So much on there. All right, so chapter 8. Then we got chapter 9. Chapter 9 is laden with formulas. So on the test, I just put them up on the board, but here you can put them down in your formula sheets. Area formulas you really should know, but here, I'll give you, what area formula do you want on here? You should know the circle. You shouldn't have to put that down here, right?
Sphere.
Oh, so volume is coming up. All right, sphere has too many dimensions for area. Well, unless you count surface area. We're not going to worry about surface area. Trapezoid, you guys always forget trapezoid. Poor little trapezoid dude. So I don't want you mistreating trapezoid dude, so go ahead and write that down. Everything else you should know. You should know the area of a triangle, because it's any triangle is half of some associated parallelogram. So, yes, how to convince yourself of that. It's true. So that's why its area is 1/2 base times height, because it's half the base times height for a parallelogram. Because any triangle is half of that. Volume. So volume, we've got. What do we got here? Let's do sphere. Then we got these guys. So the biggest mistake people made on this problem on the test, everybody had a pyramid for the last problem. Most people just were not putting the right thing in for big ass B. Why is it big ass B? Why do we make that a capital B? Because it's not just a base. What is it? Area of the base, yeah. Cool. That's why it's a capital B. It's the area of the base. So what shape is these? I love it. What shape are these for? What shape? What shape would this be for?
Pyramid.
This would be for a pyramid. I like it. That's why it's 1/3, because you cut it out of a solid block. So you cut that pyramid out so it goes to 1 point. That's why it's 1/3. This would be like for a rectangular solid. You do the area of the base times the height, right? So for a rectangular solid, is this length times width times height, right? Well, what's the area of the base? Length times width times the height. That formula always works. What about for a cylinder? What's the area of the base? What's the base of a cylinder? What shape? What's the shape of the cylinder's base? Circle. What's the area of a circle? Pi r squared. Great. So we replace big ass B with pi r squared times the height. There's the formula for a cylinder. It's crazy. I like how some of you guys are looking at this like you've never seen it before.
Which one is that?
Yeah, it's for a sphere. What's the only shape that only needs the radius, the r, to define it? It's a circle or a sphere. And the cube will tell you it's a sphere. It's 3D. Okay. So anything else we should put up here? Yes, sir.
Are you going to mark us down for writing what each formula is for?
I like you answering for me. Yeah, be careful. Don't do that because that'll push me the other direction. Oh, what the hell? Go ahead. Put them down. It's fine. Jeez. Sphere. I want to see what you guys write for these. You can't write paragraphs. You write one word next to each. You can't write examples. You can't write other notes. So on your formula sheet, you're going to turn your formula sheet in. I've had people lose points on their formula sheets because they put too much. It's not fair to people around you if you put more. So don't put more. Yeah.
So no surface area, right?
Yeah, no surface area. Don't worry about surface area. So anything else from the whole semester? Chapter 11, we only did section 11.1 as percent and decimals and fractions, so there's no real formula there. And then chapter 12, we got probability formulas. Oh. Or There's your given. There's your and. Now you are all as aware as I am of how horrible I write. So if I'm you, I would double check all of these formulas in the book. Make sure that what you read that I wrote is what it actually is. If you don't, it's on you. Okay, I think that brings us up to speed. Cool. We did a lot, man. Jeez. Yeah, we did, Jeff. You assigned way too much homework. Hold on. I assigned just the right amount. The amount that you need. And the funny thing is, you guys have got to get to the point where if I yell at you about homework, you do what you need to do to get ready for tests, for any class. So the teacher's going to put down what they think is going to help you get the class the best. And then you do the parts of it that you're able to do. And you have to be honest with yourself. I keep putting up here the people that do more homework get better grades. So that's one thing. If you don't need to do the homework to get a good grade, then that's you to figure out if you want to not do it or do it. You kind of would. I mean, that's the way it is. Right? So I try to guess what's going to help you out the best. You know yourself better. Some of you guys do. Right? Some of you guys haven't figured yourselves out yet. It'll come. All right, so anything else you think should be able to go on the formula sheets?
The slash one, that's and or, right?
Where are we at?
The probability.
Of A and B?
No, the one above it.
Probably A given B?
Oh, I do.
Yeah. All right, so now it's wide open. So that's the formula sheet. If you want to put anything else in the formula sheet, you better run it by me first. You want these points. So now it's wide open. Whatever you guys want to talk about, yes.
I'm sure this was already asked, but I guess the conversion paper, are we allowed to bring that with us, or is it going to be on the test?
Yeah, if you have it, bring it with you. Yes,
The
if you
next
took,
one?
huh?
Okay.
Well, I'm going to have them here too.
Okay.
Yeah. I'm going to have copies, but I know some of you guys kept yours. If you've written on them, don't use them. I'll give you that fresh copy. All right, because you can return them in with the test. Yes?
Can we also put the truth table formulas on here too?
There's no formulas for the truth tables. So you have to remember, you have to know. It's not a formula, it's an idea. So if I have, when is and true? When's the only time and is true?
There was that one sheet you gave us in the beginning that showed us.
About what?
It was I don't know if I have it anymore. It was all of the truth tables. That it was just like if true is true for answers.
Oh yeah, so there are ideas you have to know.
Yeah.
Yes, cool, exactly. So good, so you can study from that. Don't bring that with you to the test. I know I'm evil, but that's the whole point of that, is to know what and means. What does it imply? What is or? What is if then? How does it work? Evil Mr. Jeff wants you to understand what the hell you're doing. Man, I'm sure my calculator can do that somehow. Jeff, let me figure it out. Yes?
Can we go over without replacements?
Okay. So has everybody got this here? So everybody got what they want from up here?
Okay.
Okay. Oh. If you're heading out, you might want to get a... Let me give you guys a copy of the practice file before I forget. What's really funny, on number 18, I put the Chinese and mine up at the top. I sort of forgot I had all that free space left over there. Oh, yeah, okay. I have nothing planned as always for reviews. It's totally up to you guys.
Extra.
What's up? Oh, what happened?
Extra one?
Sure.
Oh, thank you.
Yes.
Can you go over 15 again? I just kind of forgot.
Oh, wait. I forgot. Somebody already asked me
Yeah,
about
I think he asked for
replacements.
those,
Yeah. And then I got sidetracked. So a problem like the alien problem from the test?
Yeah.
All right. So just to make one real quick, the old boring standby about, big old orange, 40 red poker chips, 11 green poker chips, and 2 blue poker chips. And I picked, let's do this. Let's pick 3 without replacement. Pick 3 poker chips, bless you, without replacement. Just to show you how the formula doesn't really care. And then I ask you, what's the probability I get a blue, and then a red, and then another red? So thankfully, most of you guys seem to understand probabilities pretty well. I still get every now and again somebody telling me that the probability of blue is 1 out of 2. But if you tell me the probability of blue is 1 out of 2, you're telling me half the bag is blue. That's what you're telling me. That doesn't make sense. So it's the number of chances to get what you want divided by the number of chances to get anything. Right, so the first one being blue would be what probability? What's the probability of blue?
2 out of 53.
Yeah, 2 out of 53. I like it. It's 2 blue out of 53 chips. Cool. And then you throw that one away. So this is without replacement. You're going to throw it away. Then it comes back as a little boomerang. And then you just put it on the ground. So what's the probability that the next one's red then? How many red are in there? There's still 40. But how many chips are there? There's now 52. Because what'd you do? You just picked one and threw it away. So some of you guys had the first number different already. But before you've written anything down, you haven't picked anything yet. The minute you write it down, you've picked it. Throw it away. Now there's one less. Now you picked another one. Now there's going to be how many? 51. And how many red are left? 39, because you just picked one right before that, didn't you? And then you just multiply that out and see what it comes out to be. I have no idea. Maybe I have a slide up here.
And then with replacement, the bottom number is the same.
Sorry, say.
With replacement, the bottom number is the same.
Yeah, if this would have been with replacement, what would have been different? So if I do the same thing with replacement, same question, is that right? I'm okay if it's not right. I don't trust my brain at this point today. It's been a crazy day. Nobody tried that out? All right. I like this bunch of numbers. I want to know what it was. No, trust me. I would trust your calculator better than my brain at the moment. So if it's with replacement, every single denominator is going to be what? 53, because it doesn't change. As you go through, you haven't changed it. You put it back in. So there's always 53 for the next chip. So how many blue chips for the first one? 2. And then there's still 40 red chips, and then you put that back in, so there's still 40 red chips. Trips. And that would be how that works. It's going to be like maybe 1.0.
It's 2.21.
All right, fine. That's close. So then whatever that is, you just multiply that out, right? Give it to me. Cool. I like it. Is that, do you see that? So that's the difference. With replacement, you just got to think. That's a blue chip. So there's one less chip, but there's still all the 40 red chips. Now that's a red chip. That's the red chip happening. It's a chance that the red chip happens. So assuming that it did happen, what happens to the next probability? One less red, one less chip. If there was a fourth red chip, a fourth chip, a third red chip, that would be 38 out of 50. It's crazy. So we didn't do a problem with 3 selections, but you see how it's no different. You just tack on another little dude at the end. Keep on going. You can keep on going, pick 28 chips. Go a little insane.
Can you go over the independent, being independent?
Oh yeah, okay. Yeah, that one, I just kind of wrote that one off, I think, a little bit. Desperately someday want to figure out how to say this. There is nothing that says that the probability of one thing has to equal the probability of another separate thing. Right? Just because rolling flipping a coin and getting ahead is the same probability as rolling a die and getting an odd number doesn't mean a damn thing about them. And if they're different, I'm not going to go, oh my God, no, they're 2 different events. They don't have to be the same. So what you want to look at is how one event affects the other one. So they have to get in there and mess with the other dude somehow. And the only thing we have, so if the probability of A is the same as the probability of A given B, so if B happens and A doesn't care, do you see how that's what that says? In English. In English it says B happened and A didn't give a shit. Right? Because it stayed the same probability. It's like, oh, that's nice. I don't care. Do you guys kind of follow what I'm saying? So, I mean, if the day before a big test at 7 in the morning, you had 5 beers, do you think that might affect the grade, or at least the chances of a good grade? Yes. So those would be dependent on each other, right? I'm not suggesting that you run an experiment. Don't tell my dean, well, he said to try. Cool, right? So then the probability of good grade given too many beers would not be the same as the probability of good grade by itself. Right? Okay. If any of you drink at all, but my friend Scotty would get better and better at pool as he got more and more drunk. I'm like, this is not fair. I just get worse. I start bad and I get worse. He starts great and gets better and better. I'm like, stop it. Just stop. I'm doing amazing. Boom. Sounds like, holy crap. All right. So that's the idea of independent. You can't do A and B separate. They have to mix with each other, and that's the mixing. You've got to look at this. So if you look at your test, everybody on number 5, if you look at part A and you look at part E, those are what you have to reference to answer part F. Everybody. So part A was the probability of one thing, and part E is the probability of that given the other thing. So if it's different in part E than it was in part A, then they must be dependent. Depending on if that happened, then the probability will change. Does that make sense? You can't answer the question by saying, well, yeah, some people... No, the minute you start saying that, you're wrong. You've got to show me numbers. You've got to show me this, that those are the same.
Can you do expected gain or loss?
Say again?
Expected gain or loss.
Oh, yeah, like number 3. All right, so let's say, all right, I got my bag again. Let's make it a room. In this room, I've got it. Let's see. Let's see. All right, Marcia. I've got 15, for example, we'll just make it that. 15 blue chips, 4 green chips, 2 red chips. This works well enough. My creativity is 0 right now. And I say, if you reach in the bag and if you pull out a blue marble, I'll pay you $1. Right? There's a lot of blue marbles. You should play. And if you pick a red marble, you pay me $12. But it's not going to happen. It's only 2 red. And if you get a green marble, you pay me $15. Right? There's a lot of blue marbles. You should play. So what's the expected value going to be? So some of you guys didn't bring probabilities into this at all. You just kind of added these numbers up, but you have to bring probabilities into it. And then some of you guys didn't pay attention to, was it a loss for Billy Bob or not? Right? Was it Billy Bob? Yeah, poor Billy Bob. So what are the outcomes? Now let's say for you, what's your expected value for you? If you pick a blue, how much will you make? Or do you have to pay? If it's a blue, what do I put here? +1, right? Because you get a buck. You get a buck from me. And what's the probability of a blue? 15 out of 20. Kick ass. And then there's a green, and if you pick a green, what happens?
15.
You lose $15, right? So it's got to be negative, or else it's not going to work. It's going to look better than it should. And what's the probability of a green? 4 out of 20. And if it's red, you pay 12. And what's the probability of a red? 2 out of 21. So what always has to happen with these? What makes sense? What must these add up to be? Well, 21 over, which is also known as the sum of all the probabilities has to be 1, or else you left somebody out, right? And then what do you do with these? Yeah, 15 out of 21 of the time you make a buck. So you multiply. So this would be 15 out of 21 minus 60 out of 21. This is why you don't reduce the fractions, because they have like denominators for you. You guys see that? Don't reduce the fractions. They're already LCD. That's beautiful. And then this will be negative 24 over 21. So if you add those, you'll get your expected value. Yeah, so negative 69 over 21, which is a lot. Something, right? Negative 3.42. All right. I'm trying to remember the trick for 7.
Negative 3.285.
So like a loss of $3.29 on that. So if you played this game 100 times, how much money would you have lost? $329. Every time you play the game, you have an expected value of negative $329. That doesn't make a damn bit of sense for one game. If you just do this once, could you lose $3.29? No, you can make $1, you can lose 15, or you can lose 12. So that doesn't make any sense for one turn, right? Probabilities don't make any sense for one thing. The probability is a head is 50%. What the hell is that? If I flip it, it's a head or a tail, man. It's not half of a head. What the hell? But probabilities mean something in the long run. So if I play this game 100 times, I'll probably end up losing somewhere around $329. Right? So whoever plays this game is crazy. This is a good representation of a lot of games in casinos. They give you that one big flashy, you could win $2 million. The probability of that is very low. Or if you lose everything, the probability of that's very high. Here, have a drink. Don't think, just drink. Is that cool? Whoever asked that question, are they still here? Who asked that question? Okay, good. I'm glad. If you would have left, I would have been like, Okay. Can't believe it's already December. Yeah.
How'd you get the, on the SPX thing, how'd you get the third column?
Here?
Yeah.
Oh, multiplying these. In fact, I can't remember the book gets into this much detail, but it's x times p of x. Just multiply. Sure.
Can you do a PQR problem?
Like a table?
Yeah.
Okay. So I'm just going to kind of throw some symbols up and make up something to look at. There you go. That looks yummy. That's not the word I would use. All right. So then I got. Well, let's see. Let's do this also. So what goes up here?
PQR.
And some of you guys have developed your own ways of doing this. As long as you can tell what you're doing, it's awesome. There's ways you can kind of cut down on the time of these problems. Beautiful. That's the whole point of math. We say, here's the idea, and you say, well, let me work that better for me. That's how math is supposed to work. So there, I don't know if you guys remember how to do this. The P is the one that doesn't change much. Then the Q goes a little bit crazy. True, true, false, false. True, true, false, false. And then the R goes and says true, false, true, false, true, false, true, false. You can also do a tree diagram, but why? Why would you? So, oh, I'm already off kilter. These all right. So what do I do first over there?
What's the P's and
So it's the same order of operations as always. So what do I do first? Inside parentheses, and I want to do this not R because I don't have not R yet. So what would not R be? False, true, false, true, false, true, false. I just want to tape that and just say this is what my class is like. False, true, false. Something like, is it so false? No. And then so P and this. And is only what when what? True when they're both true. Kick ass. So you look for both of them true. There's a both true. There's a both true, and then there's no chance here, right? So it's false everywhere else. So and is very restrictive. And now we got probabilities. And in a probability always makes the number the smallest it could be. It's got to be both, so it's very restrictive. So in logic, we see the same thing. It's very restrictive. You can only be true in a few cases. Right? Or they have to both be true. It's very restrictive. So I can cross this out. I need this anymore. That's the answer to this piece. What do I do next? If Q, then P, right? So I want to look this way. So if you're good with it, you can just kind of look. You got to think this way. And if then is only false when true implies false. So I'm looking for TF. So that's not TF. That's not TF. That's not TF. That's not. There's TF. So that would be a false. This is where lined paper would be really useful. That's a false. Oh, Jeff. Okay. Let's see. Where else do we got a false? That's a false. True implies false. Do you see that? It's pretty cool that I'm doing this because this Q implies P. So true, false. That would be false. False, false. Everything else is true. True, 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 true. False, false. True, true. So now I'm doing this dude, and who's this dude? If and only if, also known as the super equals. I like it. The biconditional. Kick ass. And that's only, or that is true when they are both the same. Because it has to work both ways. So true implies true, and true implies true. That works. The only way it won't work is if false implies true works, but the other way doesn't work. So it's got to work both ways. So they both have to be the same for it to be true. So let's see, where are they both the same? No, yes. No, yes. Yes. Yes? No, no. So everything else is false. What? You circle that bad boy because that's your answer. So again, it's just built, if you remember, you're only ever comparing two things at once. So if you just remember those little phrases, and is only true when they're both true, or is only false when they're both false. You're only ever comparing two things at once. You build, build, build. All right. This kind of thing, this kind of math is used, it is used in philosophy. It's used, there's a whole, logic is a philosophical thing. Math used to be just pure philosophy. Mathematicians were called philosophers. Right? So this kind of math is used throughout logic. It's the underpinning of a lot of it. And then, of course, it's used in computers, like I told you guys, circuitry, stuff like that. All right. Be real careful. If I tell you that P is true, Q is false, and R is false, don't make a table. I'm just telling you to plug those values in. Don't waste your time making a table and then circling one answer. You wouldn't do that. That's insane. You don't want all these. I just want that one. So if I said P is false, Q is true, R is true, you just do that. You plug it in and you get false and you're done. Not false. Get true. There's the answer. All right, just plug the values in. Don't make a whole table. That's just wasting time. All right, then you're like, you made a long test. I'm like, no, I didn't. You made it longer. Yep.
Can you number 8 on the practice diagram?
Oh, yeah. So what's wrong in the very first sentence? What's kind of something I got to take care of?
One's in inches and one's not.
Good. One's in inches, and the other one's meters. That could be whatever. Let me see what it is. I forget what it is. There it is. One's in decimeters, and the other's in inches. Cool. So cylinder, 45 decimeters in diameter, and 2,510 inches high. And part A says, what's the volume in cubic meters? So I'm telling you what to convert everything to. I want to make everything in terms of meters. Where's the cubic come from? The cubic is when I plug it into the volume formula and the meters multiply. So I want to make this in the meters and that in the meters. And what's wrong with this? That 45 number. Why is that not quite what I want?
The formula needs radius.
Formula needs radius. Yeah. So the formula, area of the circle is pi r squared times h. So I need the radius. So the radius in decimeters would be, what do I do to this to get the radius? Half of it. So 22.5 decimeters. How do I convert that into meters? From decimeters to meters. Just have to take how many steps where? So remember, King Henry died Monday drinking chocolate milk. So I'm here, just going to take one step back. So I move the decimal. So this radius is 2.25 meters. So what about this guy? Oh, shit. How do I change inches into meters? What's the go-between? Inches, I can go from inches to, who remembers? Or you can look at the little, or you can look in chapter 8, if you have your book. Or you can sit here and stare at me until I tell you. I can go from inches to centimeters. 1 inch is how many centimeters?
Is it 6 or something?
2.5. Ivy, I love that. At least you said something. I appreciate that. You're like, just say something, Jeff. I don't know. All right, so obviously that's going to be something I have for you. I'm just hoping it would have stuck in somebody's brain. And then what does it tell me to do? It's not on the bottom.
It's divided.
So it's multiply, but straight across. If there was a number down here, I would divide it. Yeah. So whatever the heck that comes out to be. And that'll be in centimeters, which is not meters. I want it to be in meters. Right? So whatever number I get, I have to move the decimal back how many places? 1, 2. Cool. To get back to meters.
Are we gonna have a lot of those in the test?
No. A lot like this one?
No, not like this, like conversions.
Oh, there's going to be a few. I would expect 5 or 6 or something. You know, like temperatures mixed in there and stuff too. Right? Just like on the test I had this on there. Yeah. Is that cool? I mean, once you get this, it's like 5,000 something, right? Or no, it's more than that. It's like 6,000. I don't know. I'm guessing. You guys have
63.75.
Well, 6375.4, right, or something?
Yeah.
And then you move it, and that's centimeters. So to make it meters, you got to move it back twice. I like it. And that's the height. So you put the radius in, 2.25 times the height. Blah, 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 blah. So remember, you gotta. Part A told you what to take it to, but these are not the same. You have to make them the same. So you could have made that inches or that decimeters, but the problem wanted it to end up in cubic meters. So you're like, oh, cool, they told me, change everything to meters. So then when I put them all together, it becomes cubic meters in the volume. Hopefully that's what I did on the answer key. Certainly didn't feel familiar to me. There it is. Yay, Jeff. All right, cool. And then it's going to be on this little sheet here to do the next step, which was take it from cubic meters to liters. Right. So you can go from cubic meters to kiloliters, and then from kiloliters to liters. So you'll have that little thing. What you need to understand is how to figure out the path you've got to take. I'll have all the routes. You got to figure out the path to take. Right. It's like Google Maps. That's red. I'm not going to go that way. You guys are funny. You don't want to leave in case somebody asks a really good question. Right? Everybody's like that. Maybe somebody will ask a really good question.
Oh, actually, I have a question. On the test number 3, problem number 3, no, sorry, problem number 1, how do you figure out what the actual percent increase and decrease is?
So what was the original? The very original?
Original what?
Original number.
40%?
No, that was the percent. What was the original? The thing that you were changing. What did it start off as?
300.
Well, somebody was started off as 300.
400?
You started off with 400. Cool. That's the original. Where did you end up? What was the last number?
336?
Okay. So how different are those? What's the change? So remember, percent change is change divided by original. So how much did it change by?
What's 336 divided by 400?
No. How much did it change by? It was 400. Now it's 336.
Just do subtraction here?
Yep. Cool.
Okay.
I like it. So figure out how much it changed by, and then divide it by the original. What's really what I wanted to get there, not enough. If I got that right, but what is 40% of 40%? Well, don't freak out. How do you do that? Of means to do what? Multiply. So it'd be 0.4 times 0.4. What is 0.4 times 0.4? 0.16. So if you had this problem where it started off at 400 and you had to move it up and down by 40%, the actual percent change should be 16% change. So if you had the one that was 20/20, 20% of 20% is 4%. It would have been an actual change of 4%.
So does that still work if they're different? If they're not like 40/40 or 20?
Totally, yeah, exactly. And if you did the algebra on it, if you started with an arbitrary price, like start with x and you decrease it by, let's do 40%. Do you see that? 40% of x. So I change x by 40%. Right? So what would that be? What's 1x minus 0.4x?
0.6x.
0.6x. And then I want to increase this by 40% of it. So it'd be 0.6x plus 0.24x. So now that's 0.84x. Craziness, right? How much it used to be 1.0x, now it's 0.84x. How much did it go down by? 0.16, 16%. So you can see it in the math. So it didn't matter what number I picked, 100, 400, 200, 300, 18 million. It would have come out to the same percent change at the end. It's really not the most exciting thing in the world, but still it's interesting. It's kind of interesting. Holy crap. It is just about time to go, isn't it? Alright guys, so remember the test starts at 3:55.
So, did you take the test on Wednesday?
Yeah, the day you weren't here.
Yeah, I feel like an idiot. I think I misunderstood you because you're saying don't show up Wednesday and you're talking about this is Wednesday?
Yes.
And you're everything?
Yes.
And
Oh,
I
I
didn't
see.
show up.
So at
Is
this
there any
point,
way I can make up for that?
they're insane in the study, so whatever you make in the final is going to also count for the missing test.
Wait, what?
The final is going to count a little bit more to cover for you for that 0.
Okay, so this is what I have without this test at all.
Yeah, this is as if that test didn't happen.
Okay.
So your actual grades here won't be the same because your final is going to count a little bit more.
Okay, is there any way I can make up that?
At this point, no.
Okay.
We're already, basically when it gets to finals time, I stop doing makeups because they're insane in the testing center.
Okay.
Yeah. Cool.
What would this be?
Oh, you could do, so percent means over 100, so it could be 2340 over 100. For one thing. Because you went from this, so you can't have a decimal inside of a fraction for one thing. So you could have said 23 and 4/10, right? I think that's what you were thinking, but 23.4 can't be the same thing as 22.4 divided by 10, yeah. But I think you were thinking 23 and 4/10.
Hey, I'm just wondering, Mark told me Scarborough again.
Oh, okay, yeah.
So I was just wondering if I could get his paper. He told me to grab it from me.
Magical, right?
Yeah. Cool, thank you.
Sure. Yeah. 64 was the change divided by 416%. Cool. So that's the 16% difference there. Oh yeah, I don't know what the hell.
And if we specify line increases,
Okay.
same kind of
All right. Shoot me. You're taking it this next
I'm taking it on the left.
on Friday. No.
Yeah.
Yes. Okay. So right before I just email me a reminder, so I can send it over to them. I can tell them that. Cool. Okay.
Thank you.
Sure.
Pedro's not here. He asked me if I can grab his papers for him.
There he is. I guess he probably wants answer key. All right. There we go.
Alright, thank you.
Sure.
Are you still allowed to correct page 10?
Yeah.